Okay, so now we're going to do some examples where we're naming various compounds, and I've mixed them all together. So ionic compounds, covalent compounds, compounds with polyatomic ions, and transition metals. So we're going to go through the process all the way through for each one of these. There's 4 examples here. So we're going to start actually with the most straightforward one first, and that is this compound. Okay, so just interpreting it, we have 1 calcium, that's our cation, and with chlorine, the anion is formed from chlorine. So let's go ahead and learn how to name this guy. Okay, so when we first start trying to figure out how to name something, the first thing we have to do is figure out whether we have an ionic or a covalent compound. Okay. And remember, an ionic compound is going to be when we have a metal and a non-metal. So our metal is going to be our cation. That means it's going to have our positive charge. Okay, positive something. Doesn't have to be just positive 1. Non-metal is going to be our anion with the negative charge. Okay, again, doesn't have to be just -1. Okay. All right, so now that we know that because we have a metal and a non-metal, we have an ionic compound here. So we have to use ionic compound naming rules. All right? Okay, so when we're naming an ionic compound, first we're going to name the cation, then we're going to name the anion, and then we're going to put the 2 together, and that's the name of our compound. So let's go ahead and name first the cation. Okay. And so I see that this is calcium, and remember the cation name is just the same as the metal. And these main group elements, such as calcium, which is in the 2nd column, they don't require us to specify the charge because they have only 1 charge as a cation. And so we're going to say that this is calcium. So this is the cation name, calcium. So I'm going to write that right there, and then we'll add on to it. Now, we have to go through a little bit more trouble to name the anion, all right? And so, as I mentioned earlier, our anion is formed from chlorine. And we don't call this just calcium chlorine. We have to do something to indicate that this is an anion. So what we're going to do is take the root of the name and hack off the ending, okay? And then we're going to add IDE, okay? That's our ending. So now the name of our anion is going to be chloride, okay? And when we want to name the compound, of course, we're just going to say calcium chloride. We're going to put the 2 together. Okay? All right, so that's our first example. So let me write down another one. And here it is. Okay. So that one looks a little bit more complicated, doesn't it? All right. So there's a couple of things that you have to do here. One, if you weren't careful, you might start thinking this was a covalent compound because there are 2 non-metals there. But it's not, okay? And so there's something hiding in here, and that is this little friend, okay? And then let's go over here, and that is magnesium, right? And it's in the 2nd column, and magnesium has a charge of 2+, so we know that, okay? So this guy, again, we know what this is. This is magnesium 2+. So this is an ionic compound, but we're still looking at what is this guy. Well, if you memorized your polyatomic ions like you should have, then you would know that this is actually this anion, and its name is sulfate. Okay? So this compound includes a polyatomic ion. Now, after we figure out that we have a polyatomic ion in this compound, now we just name it according to normal ionic compound rules, because this is an ionic compound. So this sulfate anion is covalently bonded together, but it has an ionic interaction with this magnesium 2+ cation. So let's go ahead and name him, okay? So when we name the cation, it's just the name of the element. So we're going to write down magnesium. Oops. Okay. And the nice thing about polyatomics, once you have them memorized, they're easy to name because it's just the name of the polyatomic ion. So we're just going to write that down, magnesium sulfate. So that's the name of that compound, magnesium sulfate. Okay. So let's go to the next slide and do example. Okay, so here's this little friend. Okay, so he looks a little bit more complicated again also, doesn't he? All right, so let's pull this thing apart. Okay, so the first thing we're going to do, let's go ahead and look at this. So this is iron. Now, iron is a transition metal. And because it's a transition metal, it can have various cation charges. It's a metal, so it's going to be a cation, but it can have various different charges. Okay? So we're going to have to specify in the name what that charge is. But we'll come back to this guy. Because in order to figure out his charge, we have to figure out what's going on over here. All right? Now, again, if you memorized your polyatomic ions, you are going to recognize this little friend. His name is hydroxide. Okay, and so it's OH minus. So each one of these guys has a -1 charge. This subscript here means that there are 3 hydroxides. So I'll just write down 2 more. So we have all 3 of these guys in this parentheses over here. All right. So if we add up those charges, so -1 plus -1 plus -1 is going to give us -3 overall. Okay. And now that we know that this is -3, in order to have a neutral overall compound, we need to have the same amount of positive charge. And so we know that this guy, this iron cation, has to be +3. Because +3 minus 3 equals 0. And so we need a neutral charge, non-charged compound. Okay, so now I think we're ready to start naming. All right, so we have our anion name, which is just hydroxide. Okay, and so the last thing we need to do is just name our cation. And because it's a transition metal, we do have to include the charge. We have to tell people what that charge is. And so I'm going to write down iron. And then we're going to write it in Roman numerals. Iron 3 hydroxide. Okay. All right, so again, ionic compound naming rules. This time we have a transition metal, but we still have a metal and a non-metal, and that's an ionic compound. Okay? So far we've used ionic compound naming rules for everything. Now, let's do one more. So what do you think of this guy? Okay. All right. So let's pull this one apart now. Okay, first thing you should notice, phosphorus and sulfur are both nonmetals. Okay, if they're both nonmetals, then that means we have a covalent compound this time. And so we have to use covalent naming rules. And those are the ones where we use the prefixes. Okay, so we can't assume, we don't have ions anymore. So now we have to tell people what the, how many of each atom there is in the compound. Okay, because we can't just make an assessment based on charges because we do not have an ionic compound. So the way that we name these guys, so we have phosphorus. Okay, so I'm going to write that down. All right, and there are 4 of them. So I'm going to put a prefix that tells us that there are 4 of them. Tetraphosphorus. And then, now we need to name the second part. Okay, it's not quite as simple because we do have to change that ending. But we know this is sulfur. Okay, so we're going to hack off the ending, keep the root, and add IDE. Okay, so we end up with sulfide. Okay, and then we have 10 of them, and the prefix for 10 is deca. So tetraphosphorus decasulfide. Okay, so the only time that you use prefixes is with covalent compounds. If you use them in ionic compounds, it's incorrect. So make sure you have 2 nonmetals before you even think about using prefixes. Otherwise, they do not apply.